Welcome to our module 2 lessons from the test. So I have named this presentation lesson 3 module 2 and it's called lessons from the tests. Here there were not as many issues as we had in module 1. So therefore it's not going to be as long, it's going to be pretty short. And it will just highlight a few things that might have been an oversight on emphasizing, and they came out very clear that they need to be addressed in the entire class so that you guys don't get caught out when we have exams. So here is the first part of the points to note. When you have this scenario, this means that it's a positive phase sequence, okay? And you can see that because you've got an ABC scenario when you go on an anti-clockwise direction in your original network. So this one, you all knew it was not a problem. And when we looked at this, you all knew as well how to do VA0, VA1, and VA2. And you were equating them perfectly. The problem that came was with the question that says you must calculate the total active and reactive power in the load using the symmetrical components, okay? And I note using symmetrical components. So what most of you did is you went and you utilized your VAN and IAN and VBN, IBN, VCN, ICN, and you calculated your total power and reactive power. But it says using your symmetrical components. So what you had in the actual test is that you were given, you had to calculate your currents and you were given VA, VB, and VC. So you were going to go and take, because it was on A phase, you're going to go and take those currents that were given, IA0, IA1, IA2, and then you had to go and work out your VA0, VA1, VA2, and you work those out utilizing your EA, EB, EC that you were given. And how do you do that? It's there on the right hand of this slide that your VA0 would have been a third of EA plus EP plus EC. Your VA1 would have been a third of EA plus alpha EB plus alpha squared EC, and your VA2 would have been a third of EA plus alpha squared EB plus alpha EC. So that's where most of you made the mistake when you had this in line A, and it was a positive phase sequence. So for some of you, we changed the question a bit and made it a negative phase sequence, which means that in reality, all we did was to swap the B and the C phase around, okay? And when I write it out, you can see that your EA is not affected. It's still equal to what it was when it was following the positive phase sequence. But then for your EB and your EC, that's when things are now going to change. So what I did, if you look at the bottom there, I have now made the first sequence to be a negative phase sequence because it must follow what my CBA sequence is for that system. And then I've made now the middle one to be my positive phase sequence. I've just swapped around what was my positive and negative in the previous scenario so that when I look at it at the end of the day, I can see that my EB and my EC are just swapped around. And so therefore, if I'm writing now my EB, you can see that I now start in the middle because that's what I've now made my positive phase sequence so that it now follows exactly the negative, or rather it follows the CBA sequence. So my positive phase sequence in this case is not what you know as your positive, but it needs to follow that CBA sequence. So that becomes my series 1 instead of looking at it as your positive phase sequence. And then my series 2 will now be the opposite, okay? Originally, where it would have followed what would have called a positive phase sequence. So my EB then becomes VA naught plus alpha VA1, because you can see it's at the bottom there. It's at the top, sorry, on my positive phase sequence, and then it is alpha squared VA2. And then my EC simply becomes VA naught plus alpha squared VA1 and alpha VA2. And if you look now at my EB now and my EC now, compared to what I had when I was doing a positive phase sequence, you can just see that I've taken the EB and put it where the EC was and the EC where the EB was. And so that I can be able to see that the two are actually swapped around. Then my VA naught for this negative phase sequence will still be the same, a third into VA plus VB plus VC. But then my VA1 and my VA2, again, it's matter of swapping them around from what I had on my positive phase sequence. So we went and we twisted the knowledge even more for some of you. And instead of referring to line A, we refer to line B, and on some we even refer to line C, because bottom line is that you've got a three-phase system, and really any of those three phases can be transformed into a zero, positive and negative phase sequence. So as much as we've been used to doing it in A phase, in reality B phase can be done and C phase can be done. So in the test we did this, and most of you were not able to do it. What you simply did is you took that B or that C phase and you rewrote it and you said it was just A phase. You ignored the fact that it was not A phase and you made it by force A phase, which also now affected the other things that you had to calculate, because your impedances were also in A, B, and C phase, and your voltages were also in A, B, and C phase. So therefore, when you had to go and work out, you now were unable to, because everything was not matching accordingly. So this is how you needed to go about doing it. Your EA, we know that when we write it in terms of EA, it's still VA naught, VA1, and VA2. So what you need to do now is you need to write it in terms of B, because B is your reference point. And how do we go about writing it in terms of B? Is that we know it is going to be your your EA in terms of B is simply going to be VB naught, because we know VA naught and VB naught and VC naught are the same. And then your VA1 is going to be, you need to go to your positive phase sequence at the bottom there, and you can see that is alpha VB1. And then for your VA2, you need to go to the middle one, which is a negative phase sequence, and it's simply alpha squared VB2. And then your EB is now your reference point, so it becomes VB naught, VB1, and VB2. Then we go and look at our EC. If we had to write it as a VC naught, VC1, VC2, we know that's all good and all nice and clean. Now you need to go write that EC in terms of B, because B is your reference. And in terms of B, you first go at the bottom, look there where the formulas are. Your is going to be VC naught is the same as VB naught. Then your VC1, go to your positive phase sequence, and you can see that is alpha squared VB1. And then for your VC2, you can go to your negative phase sequence, and you can see it's alpha VB2. So that's how you write your EA, EB, and EC. So we go to the next slide. In the next slide, I've now shown exactly what we did in the previous slide first, and then on the right hand side, we are now going to rewrite. where we're now wanting to know what VB naught is, and it's simply a third of VA plus VB plus VC, and then we multiply EC by alpha and EA by alpha squared so that we can work out what VB1 is, and then we also multiply by alpha squared and alpha so that we can get what VB2 is going to be. So this is if your line B was following a positive phase sequence. If it was following a negative phase sequence, it means that your EA and your EC were going to be swapped around. Okay, so I didn't do a slide for that, but what I want you to note is that if I'm saying I'm swapping around EB and EC, first go to my left hand side and just swap them around. You take EC and you put it where EB is, and you take EB, you put it where EC is, and the rest of the formula stays the same. Are you guys clear? And then you do the same thing with your VB1 and your VB2. They also get swapped around. So you just take VB2, the 2 you replace by 1 and the 1 you replace by 2. And the formula on the right hand side would remain the same. We do the same thing when we had a line C. Your C now becomes the reference point. You must not go and say that that line is an A, please. So what you do is you do exactly the same thing that we did in the previous slide by rewriting now my EA and my EB to be in terms of EC. And you can see now at the bottom there that my EA is going to end up being VC naught. Plus, if I go to my positive phase sequence, it's going to be alpha squared VC1. If I go to my negative phase sequence, it's going to be alpha VC2. And then for my EB, it's going to be a VC naught. And then if I go to my positive phase sequence, it's going to be alpha VC1, and my negative phase sequence is going to be alpha squared VC2. And obviously my VC is just VC0, VC1, and VC2 together. Now I take that and I know that my EA, EB, EC will simply be equal to 3 VC0. And I've taken this and I've put it now on the left hand side so that you can work out your VC naught and your VC1 and your VC2 in those formulas. And you do that by multiplying by alpha your EA and alpha squared your EB, and then again multiplying your alpha squared EA and then alpha by EB. And that will be able to give us how we do the formulas for VC1 and VC2. And those were the twists. Okay, so it was the line B, line C, and then it was calculating your power utilizing your sequence. All right, otherwise if it had just said calculate your power, then you would have used just VA, IA, VB, IB, VC, IC in your calculations. Thank you.